So that's why we have definition of congruence. Another big thing about these types of groups is obviously they're very different than the algebra ones, because the algebra ones, you're just solving an equation. Here you have to figure out what's going on based on a diagram. And so oftentimes it'd be a good idea to go back and check what's on the diagram. If you get to something like number 3, and it doesn't seem to really have anything to do with these first two, then check the diagram and see if you can work it out from the diagram. Because if I'm looking here, I see PQ, I don't see it equal to QS or anything like that up here. These two statements here, these two additions right here, don't really seem to have much to do with either statement 1 or 2. And if they don't seem to have to do much with statement 1 or 2, check the diagram. As we go to the diagram, we got PQ plus QS. Here's PQ, here's QS, and it's equal to PS, the whole thing. Part plus part equals whole. That's going to be the segment addition postulate. And it also says the same thing for this other segment. It says TQ plus QU equals TU. So if you get stuck a little bit, and the current statement doesn't seem to have anything to do with the previous one, check the diagram. You might be able to work it out from there. You're also going to notice that we end up using a lot of the same things over and over and over. For example, definition of congruence shows up a lot. Definition of midpoint shows up quite a bit throughout these proofs. The segment addition postulate you see a lot. There's also a lot of substitution and the occasional transitive property. And transitive, I think, shows up in most of these. So let's keep going. The next 2, 4, and 5 are both substitution. So we got given, definition of congruence, segment addition postulate, and then this next one, number 4, is substitution, as is number 5. So, first of all, it's a lot to look at, right? Like trying to figure out, like, whoa, that's a lot of letters and additions and equal signs, and like, how do I figure out and piece together what's going on? If we look here, we're talking about 2 things adding together to equal a whole thing. We already used the segment addition postulate, so it's not going to be super useful to go back to the diagram right now. So if you look at the line above it, you can see that QS equals and PS line up really well. Like those things are the same between both of them. The only thing that's changed is PQ and TQ have been swapped around. And if you look at the previous statement up here, it says that those 2 things are the same. So what happened was it says, okay, we got PQ here. It's the same as TQ. So TQ has substituted in for PQ, and we've written it here. So we swapped out PQ with TQ because it said that everything were equal. So that's going to be a substitution problem. 5 is the same thing. It's just taking this other one, TQ plus QU equals TU, but QU and QS have been swapped around. QU is the same as UQ, by the way. So those 2 things got swapped out. And now it's TQ plus QS equals TU. So we have substitution again. The next one, well, there's only 2 left, by the way. We only have 2 left after that. Hey, Adrian, I got you the lesson from yesterday, right? At the end of the day? Okay. All right, so we'll keep going here. This next one, number 6, it's open season, is the transitive property. The reason why this next one is the transitive property, if you take a look, transitive property is, again, can be a tough one to recognize. So if you look here and you're like, I don't really know how to piece anything together based on what's happened before. Oftentimes it is either the one we just used, substitution, or transitive property. We basically use everything we could based on the diagram for the most part. Like we don't have anything about midpoints or anything like that. So with transitive, it always has to do with like first thing and a second thing and a third thing. All right. Hey, everybody's here. Let me get this stuff from yesterday real quick. We are just finishing up. We started these notes yesterday. We're finishing them up right now. And it's open seat. Okay. So if you have, I'm going to use some highlighters for this. This one is going to be transitive. So the first thing is PS. Because the final statement of the transitive property is the first thing is equal to the third thing, right? We got with transitive, it's if one thing is equal to a second thing, and that second thing is equal to a third thing, then the first thing is equal to the third thing. So if we just go back here, here's the first thing, here's the first thing. Here's the third thing in the final statement, here's the third thing in the in-between statements. If you want to. Sometimes colors can be helpful to kind of see what's going on. And then we got the second thing here and the second thing here. So the first thing always ends up in the final statement. The third thing ends up in the final statement. And the second thing is always in the first and second statement, but does not end up in the final statement. So first is equal to second, second is equal to third, first is equal to third. And that's what's being used on what we're looking at right now. So if you're doing some highlighting, go ahead and do that. And then we're going to flip back and finish up number 3. And we'll keep going after that. Okay. Good to go? Not yet? Okay. All right. So here we go. Back to number 3. So let's see. It says that we got PS down here is our first thing that we're going to be looking at. Move this out of the way. PS is the first thing that we're looking at here. And PS actually shows up in a couple of places earlier in this problem. It shows up in step 3 and in step 4. Most of the time, the transitive property, this is not always true, but most of the time when you use the transitive property, this is the result of the previous 2 steps right before it. So chances are we're going to be using PS from here and not PS from step 3. Because it's usually the result of the 2 steps right before where we're looking. So I'm just going to go ahead and leave this open for now. Because I don't know yet what the PS, which one it relates to. It'll probably relate to the one in step 4, but maybe not. So we'll have to find out. All right, then EF, or TU, I guess, here. TU is our third thing. TU is also in step 3, but it's also in step 5. And transitive, like I said, is usually a combination of the previous 2 steps. So do you notice anything in steps 4 and 5 that both PS and TU relate to that is the exact same thing that they both relate to? So in this step here, PS relates to TQ plus QS, right? And in this step here, TU relates to TQ plus QS. Both of these things relate to the same thing here, which means that they are equal to each other. So for example, the way the transitive property is going to work here, we got TU, we've got PS. Both of those things are equal to the same thing. They're both equal to TQ plus QS. So if you have the first thing in blue equal to the second thing in green, and that second thing in green is equal to the third thing in orange, then the first thing blue is equal to the third thing orange. First equal to second, second equal to third, first equal to third. Yeah, go for it. Just go inside. So that is our transitive property in use. It's not always in the same order each time, too. You might notice that the first thing is on the right and the second thing is on the left. It's not always left, right, left, right, left, right. Because equals doesn't matter what order it's in. So the last thing we're going to use is this basically reason number 2. If you go from 2 things that are equal to 2 things that are congruent, the same 2 things, then that's definition of congruence. That's our final step in proof number 3. All right. If you have any questions, let me know. If you're not sure yet what questions to ask, that's okay too. You might not know what questions to ask yet, which is very normal. So go ahead and turn the page. Let's look at number 4. And what's really annoying about number 4 is that the options on number 4, there's actually an error. There's a typo on number 4, which is really dumb, and I apologize for that. Some of you might have seen it. I don't know. One of them says symmetric property down here, which definitely is one of the ones we have, because we had that yesterday, right? We wrote right here, symmetric property right here. Something that we don't have is something called symmetry property. It looks like symmetric, but it says symmetry. It's not symmetry. We do not have a symmetry property. That should not say symmetry. This should say substitution. So that one right there should say substitution. So if you were working through this one and you're having a really hard time with it, I apologize. There is a typo there. It is not symmetry property here. That should say substitution because there is a substitution step. I was working through it yesterday and I was like, wait a minute, this doesn't make any sense. That is a substitution step. And then I looked there, I was like, oh yeah, we don't even have a symmetry property. We have a symmetric property. All right. Let's take a look at number 4. So statement number 1, what's that going to be? Given. All right. Statement number 1 has to be given. There it is. And by the way, you might have noticed that I am marking up my diagram with things that I'm being given. That's probably a good idea to do on your paper as well. Like if it gives you information about what's going on, definitely put that information on the diagram so you can actually visualize what's going on there. All right, so statement number 1, reason number 1 is given. Now, oftentimes the next step relates directly to the previous step. So if you look at number 1 and you look at these two things and you look at number 2 and you look at those two equations, what do you think it's going to be based on what you can see on the diagram? What does midpoint mean? Middle, meaning what? Yeah, it's going to be definition of midpoint because middle means that a segment is being cut in half, meaning one part of a segment is equal to the other part of that segment, which JK and KL are the two halves of segment JL with K in the middle. Same thing with M in the middle of LN. LM is equal to M, LM is equal to MN. That's going to be our definition of midpoint. Number 3 might have been a little bit tricky because number 3 doesn't seem to relate to anything with 1 or 2. Did anybody get reason number 3 here? It's both very, very easy, but also maybe a little bit hard to figure out at the same time. But if you're paying attention, it's very, very easy. How much information from the very top was written down in statement number 1? All of it? I'm going to ask that question again. Up here at the top, was everything from the given written down in statement number 1? No. What else is in the given statement? JK equals MN, right? That was given. Look here, JK equals MN. So what are we going to write? Given. That one's a little bit tricky, but at the same time, if you're paying close attention, it's also super easy. Not every single time you're going to have all the given information in the first step. The reason for that is sometimes the given information relates to slightly different things. These two statements up top in the given both have to do with midpoint. This one doesn't. So that's why we didn't write it in the given to begin with. It was separated out. All right, so 3, given. All right, step number 4. So we've gotten rid of both givens and we've used the definition of midpoint. Now we're looking at MN equals KL and LM equals MN. This one looks like potentially transitive. However, the transitive property finishes with 1 equation instead of 2. And there are 2 equations written on number 4. And if you look here, LM equals MN, that's the same as this year, so nothing changed here. Let's see. If it was the transitive property, it would have been, so like JK equals KL. Then we would have had something like KL equals MN here, but that's our final statement here. So what do you think happened? Substitution. Yeah, this one's a substitution one. So what happened here is, if you look at KL, there's KL right here as well. And between JK and MN, JK was replaced by MN because it says that JK and MN are the same. So it was replaced, meaning it was substituting. So step number 4, substitution. And I actually wrote transitive to begin with as well, because that was at a point where I didn't quite realize that symmetry didn't make any sense. I was like, that doesn't seem like transitive, but I was going to write it anyway. And then I was like, no, it's all wrong. The next step is transitive. The next step is the transitive property, because here's our first thing, LM. And our third thing here is KL. With that. So what we're looking for here is, what is the common bond between LM and KL? What are they both equal to? LM and KL both need to be equal to the same thing. What is that same thing that these two things are both equal to? MN, yeah. They're both equal to MN from step number 4. So the third thing, KL, is here. The first thing, LM, is here. And the second thing, MN, that's our common bond right there. In order for the transitive property to work, both of those things there need to be equal to the same thing somewhere in the previous statements. And they're both equal to the same thing in the previous statement here. So the first thing is equal to the second thing. The second thing is equal to the third thing. So the first thing is equal to the third thing. And again, it's not always going to be in a perfect order right here. You can see that it's a little bit moved around from what we normally see, but the transitive property still works. All right, 2 more statements. 5 to 6, what happened? It just flipped around, right? So what property is that? That's the symmetric property. There you go. Symmetric property for that one. And then the last one, it goes from equals to congruent, which is definition of congruent. Yep. So here's the thing about most of these proofs. A lot of them have some of the steps on there are pretty straightforward. Like definition of congruence, you'll get really good at recognizing. Symmetric property, you'll get really good at recognizing. Definition of midpoint, you'll get really good at recognizing. Hopefully you'll get good at realizing the segment addition postulate as well, because that one will be used quite a bit. It's going to be things that are going to be always a little bit tricky will be things like substitution and the transitive property. Those ones are often really challenging to see, which is why I'm taking a lot of time to explain what those look like, because transitive and substitution oftentimes get mixed up. All right, let's go to number 5. Reason number 1, given. Reason number 2, what's it going to be? What's, 2 is not given, 1 is given. What's 2 going to be? It goes from the exact same statements, but from congruent to equals. What's that have to be? It's the same thing twice, but one of them is congruent, one of them is equals. Definition congruent. Good. Definition of congruent. That's the reason number 2. Reason number 3. If you look at number 3, does it seem to have a whole lot of connection with 1 or 2? Which one is it? But like, where though? Which one from the list on number 5? Good. This is segment addition postulate. Nice. So this is not the addition property of equality, but it is the segment addition postulate. Because what it's doing is it's just going back to the diagram and it's saying, all right, xy plus yz is equal to xz, the whole thing. And then it's saying that tu plus uv part plus part equals the whole thing, tv. All right. Then, So let's see, we've used the segment addition postulate, we've used definition of congruence, we've used given. All right, what's next? Four is definitely not going to be the definition of congruence, which means it's either substitution or transitive. And this is where it gets a little bit tricky. We have to decide, is it substitution or is it transitive? Say transitive? So why is it transitive? How about that? No XZ. Yeah, maybe 5 is transitive and one of the other ones, we will see, won't we? So let's look at these equations here and these equations here. Okay. Between these ones right here, let's just look at these. We got YZ, we got XZ. The only thing that's different is here, right? In the first equations here and here. XY and UV. Do you see anything previously that says XY and UV are the same thing? In statement 2, right? XY and UV are the same. So XY was replaced by UV. What about over here? We've got UV, we've got TV. Do you have anything that says that TU and YZ are the same? Right here. TU was replaced by YZ. If you replace something with something else, substitution. Look at the list of options. Symmetric isn't, yeah, okay, not on this one. All right, so that one is substitution, which means that 5 has to be what? That'll be 6. Yeah, 5 is transitive. Here we go. Let's look at transitive again. Here's our first thing, XZ. Here's our third thing, TV. Look in the previous step. Do XZ and TV, do those two different things equal the same thing on the previous step? So the previous step, what does XZ equal? Previous step, XZ is equal to UV plus YZ, right? And then on the previous step, TV is also equal to YZ plus UV. Again, transitive property doesn't always have to be in the same order. For example, UV plus YZ is the same thing as YZ plus UV. Those two things are the same. They're just kind of flipped around a little bit. So here we go. TV is here. There's our third thing. XZ is here. That's our first thing. And then the sum of segments UV and YZ, those are our second things. So that is, once again, the transitive property. And then if you go from 5 to 6 equals to congruence, that is our definition of congruent. Okay. Let's keep going. Number 6. And then we've got more proofs after that. All right. Because we have to finish our notes after this. Number 6. Statement number 1, given. Or reason number 1 is given. Reason number 2, what's it going to be? Definition of congruence. Ralph's being silly. All right. What do we think the next one is going to be? I agree. It is the segment addition postulate, because if you look at the diagram, these two exact segments on the diagram add up to the whole thing. So if you look over here, XY is here, plus YZ here is equal to XZ, which is the whole thing. That's got to be the segment addition postulate. How about number 4? Same thing. Also segment addition postulate. It's just the other segment. Oh wait, no, sorry, it's substitution. My bad.
I told you.
Because here, I didn't look closely enough. VY. So VY plus YW. Sorry, that's my bad. VY plus YW on the diagram adds up to VW. So that's actually going to be number 5. That number 5 is segment addition postulate. Number 4 is substitution. Because on the diagram, VY plus YW does not add up to XZ, it adds up to VW, which is the next thing. So this one is the segment addition postulate again. This one here is substitution, because if you look back, we have two statements here. Two things have been swapped out, by the way, which makes substitution sometimes a little bit harder to see. So xy was replaced with vy, right here, because of that. And then here, yz was replaced with yw because of that statement. Two things have been replaced from step 3 to step 4 because of what was written in step 2. So substitution actually happened twice, which you can do. You can do multiple of the same thing as long as it's the same reason. So that'll be substitution for 4. So I apologize, it is not segment addition postulate. However, number 5 is. And then there's only two more reasons. Means that number 6 is transitive, and let's look for it again. And then the last one's definition of congruent. But let's look for transitive again. Here we go. So xz, that'll be the first thing. VW, that'll be the third thing. Do you see in previous statements xz and VW equaling the same thing? Look at some previous statements there. Do you see xz equal to the same thing as VW in any of the previous statements? It might take two other statements to find it. What's that? Number 5. So VW is equal to VY plus YW. And then does in statement report is xz equal the same thing? Yeah, it does. So our third thing is VW. Our first thing is xz. And our second thing is Vy plus YW. What? You don't have to highlight it. No. I'm highlighting it just to show you over and over how the transitive property works. You do not have to highlight it if you don't want to. All right. Now we're done with the half sheet. We don't need this anymore. We'll just end up recycling that at some point. Turn the page over. Here we go. Now we are given some things on one side and some things on another. So we're going to have to start piecing stuff together. All right, here we go. Problem number 7. Generally speaking, listen up. Generally speaking, if a given statement provides you with information that you could go ahead and put on the diagram, put that on the diagram. So if E is the midpoint of AC, what does that mean for us in terms of the two smaller segments? If E is the midpoint, yeah, what does the midpoint mean though? What does it do to a segment? Cuts it in half, yeah, it bisects it, exactly. So that means that AE and EC are the same length. It also tells us that EC is the same as DE as well. So we can also put another one right there. So based on the given information, we can say that all three of those segments are congruent to one another. Now, I don't know if we're going to use the transitive property for sure, but I know that we could use the transitive property based on three things being the same. Because if AE is the same as DE and DE is the same as EC, then AE is the same as EC. That would be the transitive property. I don't know if it's going to be used, but if you have three things that are all equal to each other, that's always a potential. All right. What's the reason for number 1? Yeah, because it always is. Now, what does the definition of midpoint give us? Because that's statement number 2. Yeah. AE equals EC. It's the thing we marked right here. If E is in the middle of A and C, then the two halves, AE and EC, are equal to each other. All right. Now the other one, statement number 3, should be really easy because it says it's given. Oh, we already wrote that. It's this one here, right? DE equals EC. Because that's the only other thing in the given, and we need to write that down because it said it was given. Transitive. And like I mentioned, if you have three things that are equal to each other, all equal to each other, the potential for transitive is definitely there. And I'm going to use highlighters again. So you got AE here. That's our first thing. And that's also our first thing there. We have DE, which is our third thing, here. And in the previous two statements, they are both equal to the same thing. They're both equal to EC. So, transitive. Okay. Now, definition of congruence means that something was either congruent and became equal, or something was equal and became congruent. So we already have AE equals DE, but we're going to write the same two things, but we're not going to write it as equals. We're going to write it as congruent. So we need the segment symbol above AE and DE, and we're going to put the squiggly above the equals to make it congruent. That's our definition of congruence. What's that? This one is definition of congruent. Right here. From here to here is definition of congruence. What happened from 5 to 6? It switched, which is which property? Symmetric. And you just do SYMM for symmetric property. There you go. And already I can tell that people are starting to recognize some patterns with certain things that are being used. The more you see it and the more you practice it, you need to look at it a lot. You need to practice these a lot in order to actually kind of get a rhythm. So let's keep going. So right here, it says that RS is equal to half of RT. So that is going to be used. However, if RS is half of RT, doesn't that mean that RS is the same as ST? Yeah. Like right away? Okay. So let's go ahead and mark that. RS and ST are the same. What's reason number 1? Given. You got it. Are we racing? How about number 2? Yeah, why is that, Rob? Yeah. So this is a multiplication property of equality. Remember, our algebra stuff can still show up. And the reason is because the RS went from one of them to two of them. And over here, we went from half of RT to all of RT. If you double 1/2, it goes to 1, which is 1 here. If you double 1, it goes to 2, which is 2 here. So we multiplied by 2 on both sides, which means that is the multiplication property of equality. Nice. Okay. Next one, it says we're going to use the segment addition postulate. So that means we need to use the diagram to make that statement. Good. RS plus ST equals RT. Part plus part equals whole. Segment addition postulate uses the actual segment and the parts of it, and it adds the two parts together to equal the whole thing. Okay. Now, we have twice the measure of RS is equal to RS plus ST. Yeah, it's got multiplication and addition, but the previous one also had addition, so it's not going to be addition. Because it's added, like these two things are still the same things that are being added. What's that? If it was multiplication, then RS would have had to have been here as well, like RS by itself. And if we doubled it from here to here, then this would be 2RS plus 2ST. Symmetric property close. The reason why it's not the symmetric property, yeah, it has flipped around a little bit, but it's not the exact same thing that was flipped around, right? I hear substitution. What was substituted? The 2RS and the RT. So take a look here. RT was replaced by 2RS. RT is equal to 2RS.
Oh, I get it.
Substitution. Nice job, Matthias.
Wait, I said that the first time.
There's no way I wouldn't have heard it because you always talk loud enough. All right, which is a good thing. I like being able to hear when people talk. All right. So last one here, not last one, but second to last one, RS equals ST. Transitive, there it is. And you probably noticed a lot of the time, the step after substitution is oftentimes the transitive property. That will happen a lot as well. So again, here's our first thing, RS. And then here's our third thing, ST. And then let's see, where are those equal to? RS and ST. Actually, ooh, you know what? It's not though. It's not the transitive property. I lied. It's not transitive. It's not transitive. No, that's the only thing that was given right here. All right, you ready for this? Anybody find it? Anybody know what it is? What is it?
Where are we?
Sorry, it's not transitive. I said yes too soon to that. What is it? Symmetric? Not quite. Because symmetric just means the whole thing was flipped around. Reflexive? Something is equal to itself. That's not the same thing twice. How about this? You ready? Let me show you. Does it make sense now?
Yeah. Wait, why you spell transitive?
I said yes too soon. It's the subtraction property of equality because RS was taken away from both sides. They cancel out here. You had two of them there. You took away one of them. There's one of them left. So ignore my highlighting rambling down there. That doesn't make sense. It's subtraction property of equality. All right. Last one here. Actually, here's a quick hint for you. Your last statement will always be
RS is ST.
the thing that you are trying to prove. S is the midpoint of RT. This will always be your last statement. So we're just going to write that. Kind of like your first statement is always the given. Your last statement is always the thing next to prove. Okay. So S is midpoint of segment RT. All right. Because of the definition of midpoint. So we didn't actually use transitive on that one. This is one of the few ones we didn't use transitive with. All right. Let's go ahead and actually, you know what? I'm going to give you 2 minutes. Try to figure out number 9. You can work with somebody else. That's fine. But try to work through number 9. You should definitely get reason number 1. And you should definitely get statement number 6. With it? Yeah. Does anybody have the pass, by the way? I think... Oh, okay. Bring it on up. Sharing is caring. Let other people use it. How was breakfast? What was it? Just a cookie? But that's it?
Yeah.
And no.
Well, that's all right.
Wait, are you Santa?
No.
Okay. Actually, everybody should get reason number 1, everybody should get statement number 3, and everybody should get statement number 6. Like, there's no reason not to get those ones. And I'm even going to write those in just because there's no reason to not get those 3. Yeah. Cool. Good so far.
Well, you have to answer.
Well, I mean, those three are like part of the problem. So hopefully you got those ones. I marked things on the diagram as well. And oftentimes when you have three things all equal to each other, you end up using the transitive property, which it tells you you're going to use on this one. Hey, what's reason number 4? Somebody tell me that real quick. Reason number 4?
Yeah.
What's the statement right before it say? What does the statement right before number 4 say? Definition of midpoint. I'll give you a hint for statement number 5. There's your hint for statement number 5. It is a transitive property. It tells us that. There it is. By the way, the statement number 6 and its reason is also a clue as to what statement number 5 is. Because if you finish with a statement of congruence, and the reason was definition of congruent, that means the thing before it had to be those two things equal to each other. So LM equals NO. Cool. All right. Turn the page and guess what? More problems, but look at them. They're all blank. Oh, shoot. Okay. All right, here we go. What is statement number 1? What does it have to be? Why? And it's given. Yeah. So y is the midpoint of segment XZ, and that's given. Okay. For sure. The last one is going to be XY equals 1/2 XZ, for sure. XY equals 1/2 XZ. Okay. And we got some stuff in between that we need to work out. Now, up on the diagram, what can we mark because of the given? What can we like draw on our diagram because of what's given? Yeah, XY is equal to YZ, right? Maybe that's what we should write for statement number 2. And why are we allowed to write that? That's the definition of midpoint. Yeah, we use the definition of midpoint to say that those two segments are congruent. All right. Okay. What's next? What's that? That's a great question. I know this is where it gets a little bit challenging, huh? Because if you don't have stuff on both sides or like all of one side, you have to fill in for the other, like it's just up to you. Like what in the world? So what have we been using a lot of times in relation to segments when we have segments? Like we have a segment, and then there's smaller parts of that segment that make up the whole segment. the segment addition postulate. Let's write that down. If we're going to use the segment addition postulate here, what are we going to say? What would the segment addition postulate be for this segment here? Okay, xy plus yz equals xz, right? I don't know why I wrote yy. That doesn't make sense. Xy plus yz equals xz. That's the segment addition postulate. Yeah. By the way, sometimes with proofs, you might not actually know what the next step is, but if you can use something related to the diagram, go ahead and try it. See if it works. See if it gets you where you need to go. All right, now, what's that? We could subtract something. I'm not sure how much that might help. Let me ask you this. What would happen here if we worked backwards a little bit? If you multiply these both by 2, that could get us to something that says like 2xy equals xz, right? Okay. So you can also, yeah, you can work from the top going down. You can work from the bottom a little bit and try to think about maybe what came before this or what could come before this. Would everybody agree? I'm not going to write this down yet, but would everybody agree that that would be a reasonable thing to happen before that?
Yeah.
Because if you double this on each side, you'd end up here, right? Pretty okay with that? Now, we're not necessarily going to write this down yet, but like, what's that? Yep. I'm also going to give you a little bit of a hint here as well. I'm going to go back up here for a second, and I'm going to say, take a look here for a second. So yz is the same as xy, right? Because of that. So that means we could replace yz with another xy, yeah? Well, we don't have what would that be? What step would that be? But like, what are we doing here? Substitution. There you go. So let's do a substitution step, moving our way down here. And that'll give us xy plus xy equals xz because of substitution. By the way, I don't think we're going to have to use every line on this one. What happens if we put these two together? That's 2xy. What did we do when we put those together? We added what though? Okay. What do you call that in algebra when you put things together on the same side of an equation? Combine like terms. There you go. Combine like terms. And then we actually don't need this step here because we can go straight from here to here. Okay. So what did we use? The division property of equality. Good. That's it. We didn't actually need this line here. So if you want to erase this final line and then write it one up, that's fine. But we got from the beginning to the end, and we worked through it. Again, I wouldn't necessarily expect you to be able to do that all on your own right now. That's why we're doing it together. But like, there's always one or two little things that end up kind of unlocking the proof. And if you get stuck and there's something from the diagram that you haven't yet used or something like that, just try plugging it in and using it and see if that gets you anywhere. If it doesn't, erase it and try something else. All right, we got two more. Let's just do number 11 and then I'll get you your assignment, okay? Because I want to give you at least a good 15 minutes of work time. Here we go. Given, we have two statements of congruence, yeah? So let's just use both of those because congruent statements can go together. So we'll write both of those in. Segment AC is congruent to segment DF. And segment BC is congruent to segment DE. And on the diagram, we can put those in as well. So let's see, AC, that's the whole thing, isn't it? So AC is congruent to DF. What I'm going to do, oh man, there's not a lot of room to do this. But what I'm going to do is this. I'm going to say, I'm going to do that because I'm trying to represent that it's the whole thing. And then DF, we'll do something like that. Just because if you're trying to say the entire segment length is the same, you can't really put the markings on the segment itself because then you might think it's only part of that segment. So, all right, and then BC and DE are the same. So BC, I'm going to do double markings. DE, I'll do double markings as well. And then we're supposed to show that AB is congruent to EF. Now, I've definitely taught this stuff a lot. So in terms of what I'm looking at here, the segment addition postulate is probably going to be needed. I would say either substitution or transitive property will be needed at some point, as well as the subtraction property of equality. And the reason why, let me explain my thinking here. We know that this is the same as that, yeah? Let's just try to create a roadmap here real quick. This whole thing is the same as that whole thing. And this is the same as that. So if we were to cut off BC and DE, two things that are the same, from something overall between the two of them that are the same, then what's left over should also be the same. Okay. So if we subtract this and this from both of those segments, we should end up with AB congruent to EF. Now we're gonna have to be a little bit more detailed than that, but like that's the general idea about what's going on. So basically, if I have two sticks that are the same length, and I cut the same distance off of each stick, the leftover part of each stick would still be the same. That's what we're talking about here. So usually, if you start with something that is congruent, oh, by the way, given. If you start with two things that are congruent, oftentimes the next statement is a statement of equality. So let's do that. And the reason why we're doing this is because we're going to end up writing some equations, and we need to write equations with equal signs and not congruent symbols. So what do we just use to say that? Definition of congruent, yeah. Anytime you go from congruent to equals or equals to congruent using the exact same stuff, it's definition of congruent. All right. Now, I don't know if we're gonna have enough room to write both of them on the same line, so we don't necessarily have to, but the next two steps, let's use the segment addition postulate on the next two steps. One of them for AC and one of them for DF. So I'm gonna write AB plus BC equals AC. Because the part of that segment plus the other part of that segment equals the whole segment. And then I'm going to do the same thing for DF. So DE. Yep. And then DE plus EF equals DF. Also because of the segment addition postulate. So segment addition postulate and then segment addition postulate. All right. So let's look at what we can do. Yeah, go ahead. How about that? Can I make a suggestion? Okay. These things here and all this stuff here. We know that AC is the same as DF, right? Because of that. So what if we said that? Substitution, so we're going to swap that out, okay. And I'm going to do a second substitution in the same step. Is everybody okay with that? Because these two things are the same as well, right? So I'm going to do this, and I'm going to put it here. Also because of substitution. So I'm gonna write both of those things, just real quick. I'm gonna write both of those on the same line here, okay? So I'm gonna write AB plus DE equals AC. That's because I substituted out BC with DE from here. And then I'm also going to substitute out DF with AC on the second equation. So DE plus EF equals AC. Substitution, yep. By the way, the reason I'm doing that is because I want to end up creating an equation that I can subtract something from both sides in order to say that the two segments that we need to show are equal are actually equal. So right now, if we look here, AC, both of those things are equal to this stuff here, yeah? So if this one is equal to this one, and if this one is equal to this one, then this one is equal to that one. What's that going to be? What's the reason? Transitive, yeah. The highlighters are probably the clue there. If the first thing, this sum here is equal to the second thing, AC, and the second thing, AC, is equal to the third thing, another sum, then that means the two sums are equal to each other. All right. What's that? The next one is actually not transitive. This one is, we're trying to show, what are we trying to prove, by the way? What are we trying to prove, though? What's it tell us to prove? So I'm going to write that. AB, segment AB is congruent to segment EF, because that's what we're trying to prove. We don't know the reason for it yet, but we know we're ending there. Which means there's one thing in between here and here that has to happen. What's the only difference? So AB equals EF. Okay. Now, that is correct. So AB is equal to EF. So our final reason would be definition of congruence then, right? So definition of congruence is our final reason. What allows us to get from here to here? Subtraction, yeah. What did we subtract? DE, yeah, DE got subtracted from both sides. So that's that part where we take both segments and we cut off the same length from each segment, and what we're left with is congruent segments, which is what we're trying to prove. So subtraction property of equality. Nice. Okay. I'm going to get your assignment. You got about 10 minutes or so to get started on this. There are 2, 3, 4, there's 5 proofs total on here. Only one of them is like the last two that we did. Every other one you have information already filled in. We only have one proof that you have to do start to finish on your own. They will pass it back. Right. You're welcome to recycle your half sheet. We don't need those anymore. Yep. 5. There you go. All right. And this paper as well, I will collect this on Thursday, okay? If you need 2 days to work through this to finish it up, that's fine. This stuff definitely takes some thinking to work through these.